Hey guys, welcome to my class Python for Beginners. Today we'll learn a little about return values and programming development. We'll write a meaningful program and you'll also start getting the hang of programming. So coming to the first topic is return values. So the built-in functions we have used, such as the absolute function or the power function and the max function, have produced results. Calling each of these functions generates a value which we usually assign to a variable or use as a part of an expression. So for example, let's create a new file for today and let's call it, since this is our 6th lecture, let's call it 6.py. Yeah. So let's say biggest is equal to max of 1, 2, 4, 5, 8 and 10. And now we print biggest. Biggest is 10. So max is a function that takes as input 6 values, 6 arguments, and the definition of max is such that it takes 6 parameters and returns the maximum out of those 6. So we fetch that value and assign it to the variable biggest. So biggest holds the value that is a return from max. The value happens to be 10 because 10 is the biggest out of these 6 values, and hence biggest is 10. Now we're going to write some functions that actually return values. First example, let's write a function that calculates the area of a circle with a given radius. So I want to say temp is equal to the value of 34159. Sorry about that, guys. 3 times the radius whole squared. So the area of a circle with a given radius is pi r squared. Pi is 3.14559 approximated times the radius squared. So here the spaces don't actually matter because exponentiation has higher precedence over multiplication. So the exponentiation is evaluated first, r square is evaluated first, which is then multiplied by pi, and now you can return this value 10. So if you call this area on circle of radius 5 and print value, you can also take arbitrary expressions which can be function calls as well. So let's say the area of the circle with radius 5 is hit F5. Area of the circle with radius 5 is 78.53975. Okay, so well, the expression in a return statement can be arbitrarily complicated, so we could have written our function more concisely by returning this value directly without having to use the temp variable. But temp variables do make debugging easier often at times, so you might want to think about what you actually want to use. It depends on your taste and what you want to achieve and what makes your life easy. You can use variables or you can return complicated expressions. Everything is fine with the computer, it just has to be fine with you. Now sometimes it is useful to have multiple return statements, one in each branch of a condition. We've already seen the built-in absolute function. Now we can write the absolute function on our own. Let's say we have a function abs absolute value. Since abs is a keyword, we cannot use it as a function name, and takes the value x. If x is less than 0, it returns return minus x, else return x. Now you print the absolute value of minus 5, and this is 5. absolute value of 10 is 10. Okay, so since these return statements are an alternative conditional, only one will be executed. As soon as one is executed, the function terminates without executing any subsequent statements. So another way to write the above function is to leave out the else and just follow the if condition by the second return statement. What I mean by that is you can just remove the else part. If x is less than 0, return minus x. Otherwise, return x. So why this works is because if the value of x that is passed on to the function absolute value is negative, the Boolean expression x less than 0 is true. So the flow of the program enters inside the if statement. It returns a minus x. Otherwise, if x is positive, it doesn't enter the if, it returns an x, which is a positive value, so you don't need to do anything else on it. You just return the value itself. So think about this version and convince yourself that it works the same as the first version. Code that appears after return statement or any other place where the flow of execution can never reach is called dead code. In these kind of functions, it is a good idea to ensure that every possible path through the program hits a return statement. The following version I'm going to show you of the absolute value fails to do so. Let's say you have a function that says if x is less than 0, return minus x, and else if x is positive, you return an x. Now the problem with this code is if the value of x entered is 0, neither the if x greater less than 0 is evaluated to true, nor the x greater than 0 is evaluated to true. In this case, the program sort of you think it doesn't return anything, this function, but in fact it actually does return something, and let's see what that is. So it returns a none. Now you say, what the hell is a none? Well, if you ask Python itself, what is a type of none? Sorry. The type of none is a none type. It's a special type. Just like the integer, string, and other types we have learned, none is also a new kind of type. Guys, let's move on to the most important topic of today's discussion, and that's incremental development. So to deal with increasingly complex programs, which suggests a technique that's called incremental development. The goal of incremental development is to avoid long debugging sessions by adding and testing only a small amount of code at a time. For example, suppose you want to find the distance between 2 points given by the coordinates x1, y1 and x2, y2. So by the Pythagorean theorem, the distance of these 2 points is, let's write it down here, is this one, x2 minus x1 whole squared plus y2 minus y1 whole squared, and this whole thing square root is the distance between the 2 points. And the first step is to consider what the distance function should look like in Python. In other words, what could be the inputs and what's the output. So in this case, the 2 inputs are the 2 points. So these inputs, these two points can be broken down further into 4 input parameters, and let's just call our function def distance takes 4 points x1, y1, x2 and y2. So as a prototype, for now let's say it returns a floating value which is 0.0. Now the first step. Now you remember the distance formula is this one. Let's just put a comment there saying this is the formula for the distance. This is Pythagorean distance. Okay. So the first thing you do is you calculate dx, and that is the difference between the x coordinates. Similarly, calculate dy as a distance between the y coordinates. Now calculate. Now since this is incremental development, you want to check if the program is correct up till now. So you say dx is dx and dy is dy. Now call this function distance on the values 3, 4, 5 and 6, and let's see what happens. So dx is 2 and dy is 2. So you entered the values 3, 4, 5 and 6. x1 here is 3, x1 here is 3, x2 is 5. So the dx should be x2 minus x1 should be equal to 2, and a program outputs the number 2. Similarly, 5 is 4, 5 is 2, dy x2, and a program outputs the same thing. So your program works correctly up till now. So now you can remove these two print statements. The next logical step is to calculate the quantity t squared. Now the quantity t squared is, from the distance formula, is dx whole squared plus dy whole squared. And now to check if your program works up till now, you say quantity t squared is t squared. Let's see what happens. It's 2 square plus 2 square, which is equal to 8. Finally, you can remove this print statement. You can say result is equal to t squared raised to the power 0.5, which is the square root of t squared. Now you can say print result, and it's 8 square, which is 2.828, which matches with the output from your calculator, because 8 raised to the power 0.5 is the same thing. So now you can happily, instead of printing the result, you can say return result, remove this thing. So the key aspects of this kind of a development is you start with a working program, make small incremental changes. At any point if there is an error, you know where exactly it is. You can use temporary variables and hold intermediate values so that you can output and check them. Thirdly, once a program is working, you might want to remove some of the scaffolding or consolidate multiple statements into compound expressions, but only if it does not make the program difficult to read. And guys, the next thing we want to learn here is composition. So we already know that a function can call another function, and this thing is called composition. So now we're going to write a function that calculates the area of a circle. Now the area of a circle, we say area of a circle is pi into radius whole square. Now we've already written the formula distance, and we have the formula for the area. Now for this program, assume that the center point is stored in the variables xc and yc, which represents the x coordinate of the center and the y coordinate of the center, and the perimeter point is in xp and yp, which is the x coordinate, the point on the perimeter, and the y coordinate, the point on the perimeter. So as input to the program area of a circle, we are given 2 points, one in the center of the circle, there's another point on the perimeter of the circle. Okay, so let's name this function area of a circle, and we pass it 4 points, the x coordinate of the center, the y coordinate of the center, then the x coordinate of the point on the perimeter, and the y coordinate of the point on the perimeter. Now we want to calculate the radius of the circle first. Now what is the radius of the circle? Because we are given 2 points from the center and the perimeter, the radius is the distance between these 2 points. So you can say radius is equal to distance of these 4 points. Finally, you want to return the area of the area takes input radius, so you give it this radius, and now you say print area of circle on where the center is 3, 4 and the point on the perimeter is 5, 6, and the area comes out to be 24, 25.13272. Now you're gonna learn another cool trick. Well, there's no explicit need to store the radius of the circle in the variable radius. Instead, what you can do is you can directly provide as parameter, as an argument to area, the distance between these 2 points. So this thing is also valid. And it's just the same thing as above, just that we didn't want to store it in a temporary variable and we call it directly, and the output is exactly the same. Okay, so guys, let's move on to the last topic of today, and that's on Boolean functions. So functions can return Boolean values, just like our area function returns a floating point value rather. There are functions that can return Boolean values, which are often convenient for hiding complicated tests inside functions. For example, let's say, okay, let's write a function, it's divisible, x, y. So what this function does is, if x mod y equals to 0, it returns the true, else return false. So the name of the function is divisible. It is common to give Boolean function names that sound like yes, no questions. Is divisible returns either true or false to indicate whether x is or is not divisible by y. We can make the function more concise by taking advantage of the fact that the condition of the if statement is itself a Boolean expression. So we can return it directly, avoiding the if statement altogether. So you can just have something that says return x modulo y equals to 0, because if x is divisible by y, then x modulo y is equal to 0, and the check x modulo y equals to 0 evaluates to a true, and you return the value. If it is not divisible by true, then by y, then x modulo y equals to 0 evaluates to a false, and you return that value. So you just return the value of the expression x modulo y equals to true. This gets your job done. Okay, so you can have an example and see if it works. Let's say you want to call if is, okay, let's say print is divisible 6, 4. So if 6 is divisible by 4, print true, but it will print false because 6 is not divisible by 4. Boolean functions are often used in conditional statements. For example, now you see the real part. Now you can say inside of some program, blah blah, you can have program that says no, blah blah blah, and now you want to say if is divisible x comma y, and print x is divisible by y. Of course, it's this way. Else might be tempted to write something like, if is divisible xy, if is divisible xy equals to true. But this extra comparison is actually unnecessary, because is divisible xy returns a boolean value, and it's comparable to a boolean expression itself. So guys, that's it for today's lecture. I'll see you around next time, and we dive into something even more important, that is iteration. Thank you.